Hello and welcome back to PA Academy. So this is the example 5. So if you missed the previous part of this example, or maybe you just come across example 5, so you'll find a link to other parts of this video, the other previous example with introduction. You'll find everything in the description of this video. And if you are yet to subscribe to PA Academy, kindly click on the subscribe button to subscribe to this channel. So now in this example 5, the question says, three ships PQR are at sea. The bearing of Q from P is 30 degrees and the bearing of P from R is 300 degrees. If PQ is equals to 5 kilometer and PR is equals to 8 kilometer, the first one says illustrate the information in a diagram, find the distance between Q and R, and then the third one says the bearing of R from Q. Now, if you are looking at this question, you might be looking at this question looks very difficult. Well, it's very simple anyway. And this is a typical example under bearing, because this question is actually from a past question. That's a WAEC past question. So let's do this. So if you can, if you can solve this example, that means you have good understanding on the question under bearing. And if you want to, you can just pause this video and try to attempt this example. That means if you've watched the last 4 examples, I believe you should be able to do this example also. So you can pause the video and try to solve this and see what your answer is before watching the solution. So like I do say in the previous examples, that when you are dealing with bearing, always illustrate it in a diagram. Always draw something to illustrate or to explain what you are solving. And you can see it here, like I said, this is a typical example. This example is gotten from past question. So you can see they say illustrate the information in a diagram, because it's expected that whenever you are doing any question under bearing, then you should always draw the diagram for that question. So let's do that. The first one says that we should illustrate it in a diagram. So let's do that. So let's look at the question. 3 ships PQR at the sea. The bearing of Q from P. Now pay attention to this. From. So the bearing of Q from P. So that means you are starting from P. So let's take this point as our P. So let's note it's P. It said is what? It's 30 degrees. So 30 degrees should be like this. So let's mark this. So this will be our Q. Don't forget, this is P. Let me bring it a little closer. So this is P and this is Q. Look at it again. The bearing of Q from P. That means from P is 30 degrees. So this point here is what is representing the 30 degrees. And the bearing of P from R is 300 degrees. Now that means there's another point R whereby the bearing from that point R to P is 300 degrees. Now we are not given. We don't know if that P is somewhere here. We don't know if it is here. We don't know if it is here. We don't know if it is here. We don't know where it is. So now in a situation like this, what you have to do is, since we know that it's 300 degrees, just draw a point somewhere and look at where 300 degrees will be. So from this point to this point is 90. When you get here is 180. So when we get to this point, it's going to be 270. That's for the 3 quadrants. Then when it is 300, so 300 is something like this. It's 300. So with this now, so if you have, with the knowledge of this, that if this is R and this bearing here is 300, so where do we think in this diagram will fit in for that? We cannot have it here, because having it here will be something like this. That means it will be like this. So it's not meeting P. So that means we are going to come down to somewhere like this. So we are going to come down to somewhere like this. Let's make it far a bit, because the distance here is 8. So that means we are going to come down to a distance like this. So not here. So I believe that is clear. So now let's bring in look at our question again. It said, and the bearing of P from R. So this is our point R now. So let me rub this off. So point R is 300. The bearing is 300 degrees. So that 300 degrees is something like this. So what we are just doing here is to add 30. Line is not looking straight. Okay. So that is it. So what we've been able to, that means this like this is 300 degrees. Now if this is 300 degrees, okay, we'll still get there. Now if PQ, so now you can now join the 2 points. Let's join the 2 points like this. Good. So now I said if PQ is 5 kilometer, and PR is 8 kilometer. PR, that means here is 8 kilometer. Now illustrate the formation in a diagram. Now with this, now we've successfully answered the first question. You can see 3 ships PQR. So PQR at the sea. The bearing of Q from P, coming from P, is 30 degrees. And then the bearing of P from R is 300 degrees. If PQ is 5 kilometer, which is the distance from P to Q, 5 kilometer, and PR is 8 kilometer, from here to here is 8 kilometer. Illustrate the formation in a diagram. So we've been able to answer the first question, which is to illustrate it in a diagram. So that's it on the first question. But we are still going to leave it because we are going to use it to solve the other 2 questions. So now let's go to the second question. The second question is, find the distance between Q and R. Find the distance between Q and R. And it's also important to note that once you finish drawing it, there's no need to draw it again. Whatever you want to do on the diagram, you are still going to do it on that first one. So now I said we should look for, find the distance between Q and R. That means the distance from this Q to this R, because we are not giving. You can see we are not giving, but we are giving from P to Q and from P to R. But we are not giving that of Q to R. So before we can do this, you can also simplify this diagram. So let's do this. Now if you look closely, now if this point is 30, if this angle here is 30, that means this one here will be 60 degrees. Now look at this point R now. Point R is 300, is on a bearing of 300 degrees. This is 300 degrees. And if you look at these 3 quadrants, it's 270. What we added to make it 300 at this point was 30. That means this little angle we are seeing here is 30 degrees. It's 30 degrees. Now, if you look at this angle here, this towards the west now. This west, like this, straight to point P, to this point P, straight to the east, is forming what we call a Z angle. Look at it. We are having something like this. Here this is point P, and this is the east, this is the west, and this is point R. This is E, east, this is the west point. And we are having this point to be 30 degrees. Now, in situation like this, that means this angle here is also 30 degrees. We call this alternate angles or Z angle. Alternate angle or Z angle. So with that, so that means we agree with me that this angle here is also 30 degrees. Okay, it's not so clear. So but that means this angle here let me write it out, is also 30 degrees. All right. So what I'm trying to do, I'm trying to establish something. So just follow along. It's 30 degrees. Now we have 30 degrees here. We have 60 degrees here. So 30 plus 60, that will give us 90 degrees. So that means this point here is a right angle. That means this is 90 degrees. So we've been able to get one angle to be 90 degrees. So let me clean this. So the reason why we are doing all this is we are trying to solve the second part, which is find the distance between Q and R. So now that we know that this entire triangle is a right angle triangle, and we know this is 5 kilometer, this is 8 kilometer. So what we are having here is we are also having just something like this. By the time we turn it around, so this will be P. I'm just drawing it again so that we can have, this will be R and this will be Q. So this will be 5 kilometer, then P to R will be 8 kilometer. So with this now, we say we should find the distance between Q and R. So for us to get the distance between Q and R, we can easily apply SOHCAHTOA, because now we have, not SOHCAHTOA. We can easily apply Pythagoras theorem. Pythagoras theorem, which is hypotenuse square is equals to opposite square plus adjacent square. If you look at this question now, this diagram, this is the adjacent, this is the opposite, and this is the hypotenuse, which is QR, which is the hypotenuse. So we can easily use the Pythagoras theorem to solve question 2, which is the distance between QR. So let's put in the values. We are going to be having hypotenuse square is equals to, so our opposite is 8, that will be 8 square plus our adjacent, which is 5 square. So our hypotenuse square, which is the same thing as QR, so let me represent it with QR, line QR is equals to, so 8 square, that will give us 8 times 8, that will give us 64, plus 5 square, that's 5 times 5, that will be 25. So that means our QR, line QR is equals to, so 64 plus 25, so that will give us 89. Hey, don't forget the square here, 89. So now let's look for the square root of both sides. Doing that, we are going to have our QR all square, then the square root is equals to 89, and then the square root. So the square root on this part will cancel the square, so we'll be left with QR, and QR is equals to square root of 89. So that will give us QR is equals to, by the time we look for the square root of 89, to give us 9.43 kilometer. And with that, we've been able to get the answer to this that find the distance between Q and R, and that is 9.43 kilometers. 9.43 kilometer. So the distance between Q and R is 9.43 kilometer. Also, now you might be, if you are familiar with this, if you have been following along, you might also be looking at, well, we can also use cosine rule. Cosine rule, maybe instead of using Pythagoras theorem, but we can also use cosine rule. But the reason why I didn't use cosine rule, why I went ahead to use Pythagoras theorem straight away, is because, look at it, if you are to use cosine rule, I'm looking for where to use. Okay, so let me rub up this so that we can have space. So if you are to use cosine rule, what we'll be having is, so that means this place will be P, small p, while this will be small r, and this Q will be small q. So what we'll be having, if you are to use cosine rule to get this line QR, which is our P, we'll be having something like P square is equals to R square plus Q square minus 2QR cos theta. Then it will be in brackets. Now, if you look at our angle now, our angle is 90 degrees. 90 degrees. By the time we put it into this as cos 90, our cos 90 will give us 0. So by the time cos 90 gives us 0, what we'll be left with is P square is equals to R square plus Q square minus 0. Now, this is still coming back to give us the Pythagoras theorem. So whichever way you want to attempt it or you want to do it, well, you still arrive at the Pythagoras theorem, because this is itself is a right angle triangle. So that is it for the second part, which is find the distance between Q and R. We've been able to achieve that using the Pythagoras theorem. So let's go to the third part of the question, which is, they said that we should look for the bearing of R. This is R. We should look for the bearing of R. So that's what we are going to be doing next. Okay, the third question is, we are looking for the bearing of R from Q. The bearing of R from Q. So that means what we are looking for is the bearing from R from this point to here. So the bearing from here, from the north straight to the east, cross over to this point, to this line that comes down to the R, to R. So let's call that theta 1. So now, okay, let me come up a bit. So let's call that theta 1. Yeah. Now, for us to get the bearing from the bearing of R from this Q, this is what we are going to do. If you look closely at this diagram, we already have this point here, this first quadrant to be 90. So what we need to get the bearing is this, from this point here to this point. Let me use the blue marker to represent it. Since we already know that the first quadrant is already 90, what we just need is to get the angle here, this angle. So let's call this theta 2. So by the time we had 90 plus this theta 2, we will be able to get. So by the time we had 90, which is this first quadrant, plus this angle here, that will give us the bearing of R from Q. Now, if you look at this, also looking at this, is we are also having a Z angle. Now this is the part that I said is theta 2. This particular part that is theta 2 is also forming a Z angle with this. There is one that comes like this. So with this point that is 30 degrees and this particular angle here, and this particular angle. So let's just call this theta 3. So now this theta 3 that we've represented here is this is it here. Theta 3. So what it means is that this theta 2 is same as having theta 3 plus 30 degrees, because this is forming an alternate angle. This angle here, is the addition of this angle, theta 3 plus 30 degrees, is forming an alternate angle. So what we are going to do now is, for us to get the bearing, what we are going to be having is 90, which is the first quadrant. 90 plus, the first quadrant here is 90 plus theta 2. And our theta 2 now, we've represented it, that will be 90 plus our theta 2 is now theta 3 plus 30 degrees. So what we need to get now is the value of this theta 3, which is this angle here. So the reason why I did this so that you can understand properly when we start solving. So let me bring this up a bit so that we can have space to start solving. So what we are going to, that will be theta 1, which is the bearing of R from Q is theta 1. So that means theta 1 is equals to 90 plus theta 3, which is this angle here, plus 30 degrees. Plus 30 degrees. This theta 2 is the same thing as theta 3 plus 30 degrees. Theta 3 plus 30 degrees. So let me clean that and let's start to let's work on calculating that. Okay, now this shape now we can also, I want to redraw it so that we can also redraw it to be like this, because you know it's a right angle. It's a right angle. So this is still our point P. This is our point R. Our angle 90 degree. This 90 degree is still here. This is still the 90 degree, and this is our Q. Now this theta 3. This is it here. Theta 3, and this is still our 5 kilometer, and this is our 8 kilometer. You might be wondering that this 8 kilometer looks short and this one looks long. It's not drawn to scale, but let me just adjust it. So that means 5, this is 8, and this is our theta 3, and this is point Q. Now, for us to get the value of theta 3, what you are just going to apply here is SOHCAHTOA. So which of them do you think we are going to use? Let's look at it together. So we have the opposite and the adjacent, and you are looking for the angle. So let's look for them, opposites and adjacent. So that's opposite and adjacent, that is tan. So we are going to be using tan. So let's bring that, will be tan theta 3 is equals to, so the opposite is equals to opposite over adjacent. So the opposite is 5 kilometer over 8 kilometer. So the kilometer can cancel out. So 5 divided by 8. So our tan theta 3 is equals to, so 5 divided by 8. So that will give us 0.625. Yeah, 0.625. So for us to make tan 3 the solution of the formula, we'll be having, so tan 3 is equals to tan inverse of 0.625. Tan inverse of 0.625. So that means theta 3 will give us, so if you look for the tan inverse of 0.625, so that will give us 32 degrees. 32 degrees. So what this means is that this angle here is 32 degrees. It's 32 degrees. We've gotten this angle here. This is it here too. This angle here is 32 degrees. So now we can easily get theta 1, which is the bearing of R from Q. Theta 1, which is the bearing of R from Q, using 90 plus our theta 3, which is 32, then plus 30 plus 30 degree. Again, this theta 3 plus 30 degree is theta 2. Is representing theta 2. It forms a Z angle. This is it, a Z angle. It comes like this. The angle is coming like this, straight down to this point R, straight to the west. So this is it. So you can see that it's forming a Z angle. Theta 2 is forming a Z angle with theta 3 and 30 degrees. So this is which is 32 plus 30. So that means our theta 2 is theta 3 plus 30, and we've gotten our theta 3 to be 32. So with that we can get our theta 1, which is the bearing. The bearing now is from the north straight like this to this point. So let me rub this off so that we can have space to just do that. So our theta 1 is equals to 90 plus our theta 3, we've gotten it to be 32 plus 30. So 90 plus 32 plus 30 will give us 152 degrees. And that's the answer to the third part of this question. That's So with that, we've come to the end of the solution to example number 5. So that's the question, and this is the solution where the bearing of R from Q is 152 degree. So if you have any question concerning this example, kindly leave them in the comment section below. If you like this video, kindly give it a thumbs up. And if you are yet to subscribe to PA Academy, please click on the subscribe button and the little bell icon. And I'll see you in the next example, which is going to be the last example, example 6. And make sure you don't mix that last example. Thank you and bye for now.